The ancients asked a fundamental question. What is the universe made out of? They thought it was earth, air, fire, water. But if that's what the world is made out of, then what is light? You can't put it in a box. You can't shake it. You can't touch it. It's ephemeral, yet it's everywhere. Light is everywhere and nowhere. Everyone experiences the epiphany of light. But the question is, what is it? And that is dogged physics for thousands of years.
Dogged physics? Doesn't that just make your day, though? Isn't that a reason to come to the office?
That's right. That's why some of the greatest minds, going back to Isaac Newton, made the first definitive studies on the nature of light. Newton, for example, took white light from the sun, shone it through a prism, and showed that all the colors of the rainbow would come out of white light, showing that white light is really a composite, a sum of red, orange, yellow, blue light.
Didn't he also recombine it?
That's right. He could also show that Roy G. Biv, red, orange, yellow, the violet, could be recombined to create white light. So Newton thought that light was in some sense particulate. Little tiny corpuscles, as he called it, made up the stream called light. So we had the first theory of light, the fact that light is based out of particles. But however, there was an alternative theory, a rival theory to Newton's theory that said that light was a wave. And there was a guy named Young who many years ago was able to show that light had wave-like properties. Think of surfing, for example. Every surfer knows that you could ride on an ocean wave, but if a second ocean wave comes at you from another angle, the two waves interfere, giving you an interference pattern, and then of course, if you're not careful, you wipe out. Mm-hmm. Well, Young showed this with light. He was able to get light, shine it through a small little pinhole, get another pinhole of light, and have these two waves collide with each other, and there it was, a beautiful interference pattern. So we now had two rival theories of light, the Newton corpuscular particular theory of light, and Young's and others' wave-like theory of light.
Now, Einstein took this the next step.
What Einstein said, and this is the genius of Einstein, he said, perhaps both are right. Perhaps Newton showed us that light has particle properties, and that Young showed that light has wave-like properties, and the two are different manifestations of the same thing. Think of like looking at an elephant. You touch the trunk, you think the elephant is a snake. You touch the legs, you think the elephant is a tree. And yet the elephant is a merger of all these qualities. So Einstein introduced the concept of duality, particle and wave-like duality.
What are we looking at?
Here, we're looking at a helium neon gas laser. It emits a milliwatt of energy, and it demonstrates that light has both particulate and wave-like nature. Look at this. It really does look like light consists of particles. It's a collimated beam, very, very coherent, meaning that all the waves are vibrating in unison.
If there were waves.
If there were waves. Now it goes through this double slit. And as it goes through the slit, it starts to interfere with itself. Waves start to crisscross other waves to create this pattern. So as we see here, the wave starts to disperse. Now, if waves were nothing but photons, individual particles, this would be a simple red dot. But it's not a red dot. It looks like a wave-like pattern. Mm-hmm. That demonstrates in one experiment both the particle and wave-like nature of light, the duality of light.
It took the combined efforts of three geniuses across 3 centuries to help us understand light as we know it today. Without them, we may as well be living in the Dark Ages.